Hello everyone. In this video, we are going to see comparison of two heuristic algorithms, which are search algorithms and uses heuristic logics. One of them is best first search, another one is A-star algorithm. Let's just see first how this best first and A-star works briefly. Best first search uses only the heuristic value. So in case of searching in a graph shortest path algorithms, usually the heuristic is a straight line distance from a certain node to the destination node. So best first search algorithm uses only that heuristic values. But in case of A-star algorithm, it will use the cost it takes to reach a node from the source node also into account. That is called g of x. Along with heuristic, it will use this. So h of x is also used, and it uses g of x, which is a cost to go to the node x. H of x is cost or straight line heuristic value to go from x to the destination node. So it uses both, so it gives an optimal answer. So if you are comparing these two, A-star algorithm gives an optimal path, but it takes some more time compared to best first search. So computation time is more, so search cost is more, and it uses extra storage. But in the case of best first, it uses less storage, and comparatively it gives a good average case complexity for searching. Search cost is less, but there is no guarantee for optimal path, and both are based on greedy. But the greedy leads to optimal path in A-star, but the greedy does not leads to optimal path in best first search algorithm. I will show you with this an example. So if you are using best first search algorithm for solving this graph, where we are going to have source node as node A. So we have source node is node A, and destination is node J. So node A is the source, node J is the destination. So here we got source. This is source node, and this is where we need to reach the destination. So that is why you see there is no heuristic given for J, but B has a heuristic value 8, A has a heuristic 10. So this heuristic value is straight line distance from A to J. This E has a heuristic 3, it's a heuristic distance from straight line distance from E to J. I has a heuristic 1, that's a straight line distance from I to J. So like this, if you have the red colored markings, that's all the numbers which is corresponding to straight line distance from that node to the destination node. Okay, so these values are cost of the edges. It is marked in this edge, near the edges it is marked. So the one which is given the red are heuristic values. So as we discussed, best first uses only the heuristic value alone. It will not consider the edge cost to calculate the path when it is searching from A to J. So starting is A, source node, we are starting from A. So how this works, let us see. So we are starting at A, and from A there is a possibility for going to two places. There is one place B and another place is F. The cost of B is 8. You see, heuristic only we have taken into account. Cost of B is 8, and costs or a heuristic value at F is 6. So this is a straight line distance from B to J. This 6 is the straight line distance from F to J. We take only this into account to select between the choices. Okay, so to select between the choices, which one to go for, I should select and it just moves on. Okay, so we'll be taking F. That means agent is taking this path. So because it is small, so that means this path might be having the path which is very quickly we can arrive at the destination J, because it is having a straight line distance of 6. So the assumption is, since it is less than 8, we have only one choice is 8, other choice is 6. So if I go via 6, I may find a path quickly, and it may also be optimal, but it's just a may. We cannot guarantee that. That's what I'm going to show it here. So F we reach. So what's the cost? This A to F is 3. Okay, so it is going this way. Okay, then from F, where can we go? We can go to G and H. Okay, so we can go G and or H, two choices, G or H. G's heuristic is 5, H heuristic is 3. So it is taking towards path of H. That means it is going like this. Okay. Then from H, okay, there is no backtracking and all from H, because as of now we got whichever is smaller, there is no dead end, we are just going on. H onwards I can reach I with the cost of 1. So we have open ends. G is 5, 8 is here, and we have I1. So we are extending this path further. We are extending this path further, because out of this one, 8, 5, 1, this is the smallest. So we are just further extending. We just see where it goes. I goes to J with the cost of 0. That's our destination. I goes to E with the heuristic value of 3 here. Okay, but we reached the destination with the cost of 0. So now, since J is reached, we are stopping this procedure. Okay, so what you have to see every time, whatever you are discovering 6 and 8, this is smaller, I am taking this route. So as of now, it's still pending. So after that, I got 3, I got 5, 3 and 8. So in this, out of these 3, which is smaller, we are taking that route. See, sometimes if I get from F, if I move on, I reach G and H. If G and H is more than 8, imagine, if G is 9 and H is 11, then you have to follow this path. But in our example, it is just 5 and 3, which is less than 8. But sometimes you from F to J may be less, 6 only. But G and H placement may be behind F, which is farther from J. Compared to F, it may be giving more distance. So, but in our case, it is lesser. So, since we don't have this kind of scenario, we are just going through in this way. 3 is taken. Now, after that, we took into I. We got this 1. So, 1 is pending. This is there. This is there. So, we took I, and then we got into 0. That's the lowest. So, that is why this route. So, whichever the open ends, so this is open, this is open, this is open, out of this we selected 3. Then open is 1, 5, 8, so we selected 1. Then open is 0, 5, 8, still 0 is smaller than 5, 8, and we reached J, so we are stopping. Okay, so there's a route. So when the best first search runs, this route gives, what is the cost for this A to J is, so this is 3. Okay, so here 3 plus 7, 3 plus 7, this is 7. H to I is 2, I to J is 3. Okay, so it is 5, 10, 15. Okay, so total is 3 plus 7 plus 2 plus 3. So it is actually cost is 15. So it gives a 15 cost. Best first search. But if we apply the same algorithm, this is the route it gave. Okay, in the A star algorithm, if you apply, what will happen? Let us see. So you are starting at A. Okay, in A star algorithm, if I do this, we have to find F here. So what is the F value? From A, we are just, there are 2 branchings. One is F node and another one is B node. What is the F value for this F node? It considers both 3 and 6. 3 plus 6 is 9. 3 plus 6 is 9 we have. B is 6 plus 8. To reach B it is 6, from B it is 8, so it is 14. So out of this one, smaller we have to select. It's also greedy, so we are just extending. From F, there is a possibility of H. H G value is, to reach this one is 3 and 7. Okay, so it is 10 is the G value. What is the H is H value? This node's heuristic is 3. So this is 13. Okay, and F goes to G also. Okay, this edge cost is 1. So 4 is the G value. what is the heuristic value from G is 5, so it is equal to 9. So we are taking, first of all we took the root of A to F. Okay, we are expanding this, then we are G now. Okay, so here I put a cross here, so we are in here, then we are in G now. Now we are expanding G because this is smaller, we are expanding G, so G goes to I. Okay, I cost is 3, that means it is 3 plus 1 plus 3, so it is 7 is the G value. From I, what's the heuristic? It's 1, so 7 plus 1 equal to 8. So what are the open-ended things? We got 8 here, we got 14 here, I got 13 here, still 8 is smaller. Okay, so that means I am further extending I is going to J and I is going to E. Okay, I is going to J at the cost of, what is the cost of going to J? This is 3. So G value is 7, 7 plus 3 is 10, 10 plus 0 because J is 0 because that's the destination. This is the destination. So 10 plus 0 it is 10. But in case of E, what happening? So if you go to E, it is 5 and 3 plus 1, this is 7, 7 plus 5 is 12, 12 is the G, and to go to the, if you go from E, if I go to J, it is 3, so equal to 15, okay, so it is not less than 10. To go to E is 12, this is G. What is the heuristic from E? This is 3, that is put over here, so it is 15, so this is bigger, this is open end, this is one open end, this is one open, this is also bigger than 10, and we have one more place over here. Okay, we came all the way up to here. This is open end, open, this is open, this is open, this is open, this is also 13, so all the open, 13 is bigger, 14 is bigger, 15 is bigger, so that means it cannot, no need to expand these H or E or B, because if we expand this minimum itself 14, even if it is expanding, it will be greater than or equal to 14. So what's the point? We already got a 10. So here, what is the root? It took AE, AF, then FG. Okay, you see, F to G, then G to I, then I to J. It took this root. Okay, so what is the cost of this root? This root cost is 3 plus 1 plus 3 plus 3, so it is 9 and 10. 10 is the total cost, okay, for this one. But what happened to our best first search? Gave a cost of 15. Okay, here we got the optimal. This is the optimal. You cannot find a root, we cannot find a root which is less than 13 at all, so it's optimal root. So AF star algorithm gives the optimal root as in here. But what happened to B? Best first search gave via this way. It's a round cost, but it is not taking some calculations. Computation wise, it is somewhat quicker. But average case only, I can say it's reducing the average case complexity. There is no guarantee that it's always reducing the computation also. Okay, so there's the difference and how we got optimal, and there is a comparison you can able to see with this example. Okay. I hope you understood. Thank you.